Hey everybody, in this video we're going to be looking at simplifying complex rational expressions, which essentially means simplifying when we have a fraction over a fraction. But first, even though we're not together, I thought we should look at this bell work problem because it ties in with the stuff that we're going to be talking about in this video. So 2x minus 1 to the negative 1/2 plus 4x minus 1 to the positive 1/2 over x minus 1 to the 1/2. Okay, so when we were looking at GCF factoring, remember we noticed that in a case where we had, say, two terms, and those terms had common factors, like I could take a 2 out from each of these, and I could take an x minus 1 out from each of these, we said when the common factor had some power attached to it, we would take the smaller of those powers. So I'm going to factor out both a 2 and an x minus 1 to the negative 1/2. Remember, factoring is dividing, so I'm dividing here by 2. 2 divided by 2 is 1, and I'm dividing here by x minus 1 to the negative 1/2. So this thing divided by itself is 1. So I have a 1 left over. And then I have my plus sign. And then 4 divided by 2 is 2. And then what about x minus 1 to the positive 1/2 divided by negative 1/2? Well, when I subtract those exponents, I end up adding 1/2 to 1/2 and getting 1. So this will be x minus 1 to the 1. Okay, so here I need to distribute. And don't forget, we still have this x minus 1 to the 1/2 on the bottom. So on top, I've got 2. I've got x minus 1 to the negative 1/2. And now here I've got 2x minus 2 plus 1 is minus 1 over x minus 1 to the minus 1/2. Positive 1/2. So I see that these bases are the same, and I'm dividing, which means I can subtract those exponents. So I'm going to have 2 x minus 1 to the minus 1/2 minus this exponent, 1/2, times the 2x minus 1 that was left over from the bracket work on top. And nothing on the bottom right now. So that's going to give me 2 x minus 1 to the negative 1, 2x minus 1. In calculus, it's going to be fine if we leave a negative exponent, but for tradition and what we generally expect in pre-cal, I'm going to move my negative down to the bottom and have 2x minus 1 over x minus 1. Okay, yeah, I would leave this. So there's our bell work, and like I said, we're going to be doing stuff with this by the end of the video. So let's take a look at simplifying complex rationals. Okay, so the most basic complex rational expression. Rational you can think of as fractiony, and complex meaning we don't just have one fraction, but we have fractions over fractions. And we know we're working with an expression, so we're simplifying. There's no equal sign, so we won't be solving. Okay, so what does this look like? It looks like 1 over x over 1 over x squared plus x. All right, well, I remember what Ms. Rowan said to me in the 7th grade. She said, you know, you have one fraction and you're dividing it by another fraction. You could write this problem as 1 over x divided by 1 over x squared plus x. And I remember Mrs. Rowan telling me that when you were dividing with fractions, you could always flip and multiply. Now, it may be that we're all done. However, I notice that there's some GCF factor in here. What can we factor out of both of these terms on top? Well, I could take out an x, leaving me with x plus 1. On the bottom we have an x, and then lo and behold, those x's, the one I just factored out and the one in the denominator, will cancel, and so my answer will be x plus 1. So when I simplify this expression over here, I get this over here, and that's much more simplified. So we're going to be doing a lot of flipping and multiplying, but that only works if we have one thing on top and one thing on the bottom. And by one thing, I mean only one fraction. In a little bit, we'll see some examples where we have more than one fraction on top or on the bottom or both. But let's practice a little more having one fraction on top, x squared over x plus 1 squared over x plus 1 to the third. Again, I'm taking this fraction and I'm dividing it by this fraction. So that's x squared over x plus 1 squared divided by x over x plus 1 to the third. So I do Mrs. Rowan's flip and multiply. And it looks like this now. And then there's some canceling that I can do. I can take out an x on these diagonals. And I see x plus 1 to the second and x plus 1 to the third. These two will cancel. X plus 1, x plus 1. And over here it's x plus 1, x plus 1, x plus 1. I can cancel these two with these two, leaving me only one of them up top. I've also got that x up top, so my final answer, x plus 1. Okay, that's as simplified as that one gets. And then let's look at one last one, where we have one fraction on top, x squared minus 1 over x minus 1 squared over x. And again, I do that flip and multiply thing. Perhaps you've seen it enough that you'll let me just flip this upside down. X squared minus 1 over x times, flip this upside down, x over x minus 1 squared. Well, most students see this canceling, and that's great. But what a lot of students miss is this difference of squares. We need to factor that difference of squares. It factors as x minus 1, x plus 1. And then down here, we have x minus 1 squared. So we have x minus 1 times x minus 1. So this will cancel this, and my final answer will be x plus 1 on top and x minus 1 on the bottom. All right, so that's essentially how simplifying complex rational expressions works. But then we come to a situation like this, where we have 2 over x minus 3 over 1 minus 1 over x minus 1. Well, that thing about flip and multiply that Mrs. Rowan talked about only works when we have one thing up here, one fraction up here, and one fraction down here. So I think I'm going to have to combine these fractions into one, which means I need to make a common denominator. Here I'm going to multiply by x over x, and here I need to multiply by x minus 1 over x minus 1. And so this is going to turn into 2 minus 3x over x. Right, there's the 2, there's the minus, there's the 3x, and they have the common denominator of x. Over, what do we have here? Our common denominator is x minus 1. And on top, we have 1 times x and 1 times minus 1 minus 1. Now, I can, of course, tidy that up. Minus 1 is minus 2. so x minus 2. Okay, now I've got one fraction on top and one fraction on the bottom, and I'm comfortable doing my flip and multiply. 2 minus 3x over x times, don't forget to flip this, x minus 1 over x minus 2. All right, do you see any canceling on the diagonal? I do not, so my final answer would be 2 minus 3x, x minus 1 over x minus 2. Okay, let's look at a couple more of those. How about we have 2x over x plus 2 minus 2 over x. Negative 2 over x plus 3x over x plus 2. Again, I'm looking to make common denominators. The common denominator on the bottom is not x plus 2. I know you see this x and you see it here, but these things are joined with addition. That makes this its own factor, which is separate from this. So I need to multiply over here by that free-floating x over x, and over here by x plus 2 over x plus 2. Likewise, I need to do that in top. I see I've got x plus 2 again in x, so here I'm going to multiply by x over x, and here I'm going to multiply by x plus 2 over x plus 2. I've got x times 2x, which makes 2x squared. I've got this minus sign. And then don't forget, you need to distribute this 2 to both of these, which is why I put those parentheses there to remind me that that's something I need to do. Okay? So let's make sure we do that. And so we've got minus 2x minus 2. And on the bottom, we've got our x and our x plus 2. Then, in the denominator, I also was making a common denominator. I need to distribute here. I'm going to have negative 2x minus, that is distributing, minus 4, then our plus sign, and then 3x times x makes 3x squared. And this is all over the common denominator, x plus 2. Okay, so I see on top one fraction, and I see on the bottom another fraction, and I see this fraction bar in between. So I can flip and multiply now. I'm going to have 2x squared minus 2x minus 2 over x plus 2 times, flip this one over, x plus 2 over negative 2x minus 4 plus 3x squared. Well, here we can see that this x and this x cancel, and that this x plus 2 and this x plus 2 cancel. Now, what about canceling here? Well, I kind of want this in descending order. And I wonder, does this factor? Are there any factors of negative 12 that add up to negative 2? 6 and 2? No. 4 and 3? No. So I'm not going to be able to factor this. Here, I could take a 2 out of everything, and I'd be left with x squared minus x minus 1. But that's not going to be able to factor. So I'm done at this point. Okay, watch out for little mistakes as you do these problems, especially when making the common denominator, and especially when distributing and combining like terms. Okay, that was problem number 5. Let's take a look at 6. 1 over x minus 1 over x minus 1 over x plus 1 plus 1 over x. Okay. So I make my common denominator. This needs an x minus 1 over an x minus 1. This needs an x over an x. This needs an x over an x, and this needs an x plus 1 over an x plus 1. So when I write this as one fraction on top, I'm going to have x minus 1 times 1 minus 1 times x over x minus 1. On the bottom, I've got x times x for x squared plus 1 times x times 1. And that's going to be x plus 1 over the common denominator x plus 1. So again, I've got one fraction on the bottom, one fraction on the top. Ooh, but we can tidy this up a little, can't we? X minus x. Those x's are going to cancel, and we're just going to have that negative 1 on the top. So I'm going to have negative 1 over x minus 1 times flip. Don't forget to flip this. X squared plus x plus 1. Okay, so these don't cancel because one's minus 1, one's plus 1. But the x's out in front will cancel. So I'm left then with negative x plus 1 on top, and on the bottom x minus 1 and x squared plus x plus 1. All right. Well, let's take this a little further. What if we have something a little more complicated on top, like 3 over x squared minus 3x plus 2 plus 2 over x squared plus x minus 2 all over 2 over x squared minus 4 plus 3 over x squared minus 1. Wow, there's a lot of stuff going on there. Well, luckily, we're all comfortable with factoring now. This is a difference of squares, and it factors as x minus 2, x plus 2. And there's another difference of squares, but it factors as x minus 1, x plus 1. And here we have some trinomials. This trinomial factors as x minus 2, x minus 1. And this trinomial is going to factor as x plus 2, x minus 1. All right, well, let's see what we have in common. Up top, I see these both have an x minus 1. This one has an x plus 2. This one does not have that, so this one's going to need an x plus 2 over an x plus 2. And this one has an x minus 2, but this one doesn't have that x minus 2, so it's going to need an x minus 2 over an x minus 2. Now on the bottom, I don't see anything the same. I've got x plus 2, x minus 2, x plus 1, x minus 1. So this is going to need an x plus 2, and this is going to need an x minus 2. And this one's going to need an x minus 1, an x plus 1. All right, so let's go back to the top. I need to distribute. I'm going to have 3x plus 6, then our plus sign. Then I need to distribute some more, 2x minus 4. And all of that is over x plus 2, x minus 2, x minus 1. Of course, there's some tidying we can do here. We can get 5x plus 2, and on the bottom, x plus 2, x minus 2, x minus 1. All right, that's the numerator. That's all this stuff up here. Now let's deal with the denominator. Here, if I FOIL this out, I get x squared minus 1. So 2 times x squared minus 1. is going to be 2x squared minus 2. Then we have our plus sign. Now here, this is going to be, when I FOIL it out, x squared minus 4. And I need to distribute this 3 to each of these. So I'm going to have a 3x squared, but 3 times negative 4 would be negative 12. All over x plus 1, x minus 1, x plus 2, x minus 2. Well, is there any combining of like terms we can do here? Sure. 3x squared plus 2x squared is going to be 5x squared. And minus 2 minus 12 is minus 14. So if I do flip and multiply, I've got x minus 1, x plus 1, x minus 2, x plus 2 on top now. And on the bottom, I have 5x squared minus 14. So what canceling can we do? Well, I can cancel this x minus 1 with this x minus 1, and this x minus 2 with this x minus 2, and this x plus 2 with this x plus 2. So I'm left on top with 5x plus 2 and an x plus 1, and on the bottom with 5x squared minus 14. If this were factorable, I should factor it because maybe there could be some more canceling. But this is not a difference of squares as written, and I don't even have any GCF factoring I could do. So I stop here. Okay, we'll do one more tricky like that, and then let's take a look at bringing us back towards the bell work. Okay, so we've got 1 over x squared minus x minus 6 plus 4 over x squared plus x minus 2 over x squared minus 4x plus 3. Nope, sorry, it's 1 over x squared minus 4x plus 3 plus 2 over x squared plus x minus 2. Well, again, I can't see what my common factors are until I factor these trinomials. This trinomial factors as x minus 3, x plus 2. You can see why it is that we wanted to get comfortable with our factoring skills before we got to this material. This trinomial is going to factor as x plus 2, x minus 1. This trinomial is going to factor as x minus 3x minus 1. And this trinomial is going to factor as x plus 2, x minus 1. Okay, so when I look at the numerator, notice we've got this common x plus 2, so we don't need any more of those. But this one has an x minus 3 and this one doesn't, so this one needs an x minus 3 over an x minus 3. And don't forget, you're going to be distributing this 4 to each of these. Now, this one has an x minus 1 that this one doesn't have, so over here I need to multiply by x minus 1 over x minus 1. On the bottom, I see they both have x minus 1s. This has an x minus 3 that this doesn't have, so I need to multiply by x minus 3 over x minus 3. And this one has an x plus 2 that this doesn't have, so I need to multiply over here by x plus 2 over x plus 2. Okay, so back to the numerator. I'm going to distribute the 1 to each of those and get x minus 1. Then we have our plus sign. And then I've got 4 to distribute to each of these. 4x and positive 4 times negative 3 is negative 12. And that's going to be over x minus 1, x plus 2, x minus 3. Now, in the denominator, we've got 1 times x plus 2. Then we've got our plus sign. And then we've got 2 to distribute to each of these things. 2 times x minus 2 times 3 all over our common denominator x minus 1, x plus 2, x minus 3. All right. Well, I see some like terms I can combine here. 1x plus 4x is 5x. Minus 1 minus 12 is minus 13. So I get 5x minus 13. And then down here I've got 1x plus 2x for 3x. And I've got 2 minus 6, which is negative 4. So this is going to become 3x minus 4. Okay. So where are we now? Well, now I'm ready to flip and multiply. So this is going to be 5x minus 13 over x minus 1, x plus 2, x minus 3 over 3x minus 4, x minus 1, x plus 2, x minus 3. Oh, I didn't flip and multiply. So then times x minus 1, x plus 2, x minus 3, flip 3x minus 4. So what canceling can we do? Well, on the diagonal, these will cancel, and these will cancel, and these will cancel. And so we'll be left with 5x minus 13 and 3x minus 4. Now, if you could factor either of these, you should, because there might still be some more canceling. But this is as far as we can go with this problem. Okay, let's take a look at these problems now. I promise you problems like these next 4 on your next quiz, maybe even the CFA. I'm really quite taken with all the ways we can approach these problems. Plus 4 x minus 1 over 1 square root of x minus 1. Now, I'd like to look at doing this problem 2 ways. One way is the way we've been talking about in this video, where we make a common denominator. So, because I have fraction over fraction, and then do flip and multiply. So this needs a square root of x minus 1 over x minus 1. Ooh, look, there's already an x minus 1. So when we do this, we're going to have 2 plus 4x minus 1 times square root x minus 1 over square root x minus 1. And then we've got this over square root x minus 1 over 1. So it really is a fraction over a fraction. We've got a complex fraction here. So I'm going to do the flip and multiply thing. I'm going to take this, flip it upside down, and multiply. So now what? Well, look, you have an x minus 1 under a square root and an x minus 1 under a square root. What do I get when I multiply square root of x minus 1 times square root of x minus 1? Well, that's the same as square root of x minus 1 squared, which is just x minus 1. So my denominator is going to be x minus 1. On top, I've got a 2. And I've got a 4x minus 1 square root x minus 1. Now, there are many students who want to cancel these, but this 2 doesn't also have an x minus 1. And I would need all 3 terms joined by this plus and minus. I would need all 3 of these terms to have the x minus 1 in order to cancel 1 out. So what I'm saying is this is as far as I can go. No, I'm not going to distribute this square root to each of these. And it's not worth my time to distribute here. I mean, I could, but I'm never going to be able to combine this 2 because even though it looks like 4 times negative 1, hey, Mr. Kukla, you've got negative 4 plus 2, except it's negative 4 times this stuff, and it's 4x times this stuff plus 2 more. That 2 won't get added to anything, so I'm done where I am right now. Okay, so that's the complex fraction approach to the problem. But I'd also like to take a look at doing the same problem, but now let's go back and use the rational exponents that we talked about back in the Algebra Basics section. On this board. So I'm going to do the same problem, except when I see square root of x minus 1, I'm going to think about that as 2x minus 1 to the negative 1/2. Okay, so I made a mistake when I did the problem originally. This was supposed to be a square root, which would make things very nice over here, huh? Well, let's go back and fix that mistake before we take a look at this other one. Okay, so here we multiply top and bottom by square root of x minus 1 over square root of x minus 1. And here, back when I thought I was almost but not quite done, I don't have an x minus 1 here. I have a square root of x minus 1 times a square root of x minus 1. Well, as we said before, square root of x minus 1 times square root of x minus 1, this is just going to be x minus 1. We still have that 4 out in front. That I need to distribute. I'll have 4x minus 4 plus 2. So we've got 4x minus 2 over x minus 1. Now I can factor a 2 out on top. 2x minus 1 over x minus 1. But these aren't the same, so I can't factor it further. But this is now what I'm supposed to get when I do the problem with rational exponents. So let's take a look at rational exponents. We also had 4 square root x minus 1. And I'm going to treat this as 4x minus 1 to the positive 1/2. And all of this was over square root of x minus 1. And again, I'm going to treat that as x minus 1 to the 1/2 on the bottom. So I'm going to rewrite my fraction as 2x minus 1 to the minus 1/2. And then we had our plus 4x minus 1 to the 1/2 over x minus 1 to the 1/2. So on top, I'm going to factor out, just like we did in the bell work, I'm going to factor out the 2, but I'm also going to factor out the x minus 1 to the smallest power. That means 2x minus 1 to the minus 1/2 is what's coming out. Remember, this divided by itself gives me 1. And then I have a plus sign. 4 divided by this 2 that I factored out would give me 2. And when I factor out an x minus 1 to the negative 1/2 from x minus 1 to the positive 1/2, that factoring means I subtract the exponent. I subtract that negative 1/2. And that's going to give me x minus 1 to the first. All of this is over x minus 1 to the 1/2. Okay, we're almost done. I need to distribute. That will give me 2x minus 2 plus 1. So 2x minus 2 plus 1 is minus 1. And notice here, these bases are the same. What can I do with the exponents? Well, I can subtract them and get x minus 1 to the minus 1. Well, because the convention is no negative exponents, I've got 2x minus 1, and I flip this to the bottom, x minus 1. And hopefully, These are the same. Okay, so I did the problem both with rational exponents, where I factored, and here I did them with complex rational expressions, where I made a common denominator. All right, let's do a couple of these. And yes, on the test, I'm going to ask you to do it both ways, not just your favorite way. Okay? I want to see you comfortable with both of these methods. So, how about 4 over square root of x minus 3 root x over root x? So, if I start by making a common denominator approach, I'm going to have 4 minus 3x, because root x times root x is the square root of x squared, which gives me that x times the 3, don't forget the minus, and the 4 out in front. On the bottom, we have our common denominator of x, and all of that is over square root of x over 1. So I'll do my flip and multiply. And now square root of x times square root of x is just plain old x. And on top I've got 4 minus 3x. Please, by all the gods, do not cancel these out. You cannot do that. You cannot do that. You cannot do that. You really can't do that. So stop thinking you can do that. It's so bad when you think you can cancel those. Look, this doesn't have an x. If they all don't have it, you can't cancel it. Okay, so this is my answer. Now, I could write 4 over x minus 3x over x and then cancel. And notice that x is still under the 4. But if you cancel these, then you think the answer is 4 minus 3 or 1. And this is the answer. That is not 1. So please do not cancel these x's. Okay. So that's the method of doing the problem with complex rational expressions. Now let's start again, and this time let's use rational exponents, and let's try factoring. Square root of x on the bottom is x to the minus 1/2. So I have 4x to the minus 1/2. Then we have our minus 3, and we have square root of x, which is x to the positive 1/2. And all of this was over x to the positive 1/2. So this is what the problem looks like if we write it with rational exponents, with fractiony exponents, and I see, oh, I can take out an x raised to a power. Which power? Well, I need the smaller one. So I'm going to factor out an x to the minus 1/2, and that's going to leave me this 4. This came out. Now we have this minus sign. This 3. Now what happens here? I'm factoring out, which means I'm dividing, so I subtract the exponent. What did I factor out? A negative 1/2. So minus a minus is plus, 1/2 plus 1/2 is 1, so this looks like that. And on the bottom, remember, we have x to the 1/2. What can I do with these? Well, I can subtract those exponents. Or as some people like to say, Mr. Kuka, couldn't I flip that down now? Sure, you could flip that down. Let's move it to the bottom and see what happens. X to the positive 1/2. When I'm multiplying and the bases are the same, I add the exponents. And so that's going to give me 4 minus 3x on top, and 1/2 plus 1/2 is 1 on the bottom. And that's where we were before. This to me looks like a lot less work than we did up here with our simplifying complex fractions. Okay, let's try 1 or 2 more of those, and then we'll call it a lesson. So, how about x squared over square root of x squared plus 1 minus square root x squared plus 1 over x squared? Okay, so if I make a common denominator here, I need to multiply here by square root of x squared plus 1 over square root of x squared plus 1. This thing times itself is going to give me x squared plus 1, not under a radical, but behind this. So On top, I have that, I have my minus, and when I multiply these together, I get x squared plus 1. In our denominator, we've got square root of x squared plus 1. And then, down below, we've got plain old x squared. All right, well, what can we do here? We can distribute x squared minus x squared minus 1 will be minus 1 over square root of x squared plus 1. And this I can do flip and multiply with, 1 over x squared. And so that's about it. I guess I could do something where I rationalize the denominator, but I would prefer not to, because that's just going to throw another radical on top without really buying me much joy on the bottom. So that's the answer that I get when I do this with complex rational expressions. But if we rewrite this with rational exponents, we've got x squared plus 1. Because this is on the bottom, it's a negative 1/2. Then we've got our minus sign. And we've got a square root of x squared plus 1, x squared plus 1 to the positive 1/2. And all of that was over x squared. Okay, so I see this common factor. I take out the smallest power, x squared plus 1 to the minus 1/2. What's left over? This x squared is. And here, when I factored a minus 1/2, minus a minus is plus, 1/2 plus 1/2 is 1. So I've got this minus sign, and now these become just 1, so I have x squared plus 1 here. And on the bottom, we still have our x squared. Well, I need to distribute that minus sign, and I can move this to the bottom. So now I've got an x squared on the bottom, this x squared plus 1 to the 1/2 on the bottom, and up here I distributed, I had x squared minus x squared minus 1. The x squareds cancel, leaving me minus 1. And that looks awfully like that. So we can do these problems two ways, and you're going to have to do these problems two ways on your next quiz. So how about this one? X over x plus 1 to the 3/4 minus x plus 1 to the 1/4 over x squared. And I have a little note next to this saying, ew. Let's hope it's not that bad. Okay, so first, fractiony way. This fraction needs this denominator, so it needs an x plus 1 to the 3/4 over an x plus 1 to the 3/4. Now, when the bases are the same, they're both x plus 1, and I'm multiplying, what do I do with these exponents? I add them. 1/4 plus 3/4 makes 4/4 or 1. So I'm just going to have x plus 1 to the 1. There's that minus, and in front of that I have that x. On the bottom, I have x plus 1 to the 3/4 as my common denominator, and under that we have x squared over 1. Now I only see two things left to do, distribute and combine like terms, which gives me negative 1 over x plus 1 to the 3/4, and flip and multiply, times 1 over x squared. So finally, I get negative 1 over x squared, x plus 1 to the 3/4. Now you could rationalize this by multiplying top and bottom by 1/4, x plus 1 to the 1/4, but I don't really think it's going to buy you all that much. And since we don't use slide rules anymore, we're not terrified to have radicals and denominators. So this is the way I would do the problem. with rational exponent, I mean not with factoring, but by making a common denominator. Let's go and look at this again, this problem again here. And think about, and don't lose that x squared on the bottom. And think about doing this just with rational exponents. So here all I need to do is flip this out, which means I'm going to have x plus 1 to the negative 3/4, then my minus sign, and then the x plus 1 to the positive 1/4. And on the bottom, we have x squared. Okay, well, let's see. We've got a common x plus 1 here that we can factor out, and we always factor out the smaller power. So I'm going to take out an x plus 1 to the minus 3/4 and play the what's left over game. Well, I just took this out, so this is gone, and I just have this x. Now we have our minus sign. And then what's left over here? I factored a negative 3/4 out. So 1/4 minus a minus 3/4 is 4/4 or 1. So I get x plus 1 to the 1. And don't forget on the bottom we have x squared. Okay, so I distribute that minus, and I have x minus x, they cancel. Negative times 1 is negative 1. I also see this negative exponent and think to flip it down. And so I end up with negative 1 on top from this. This moved to the bottom, this is on the bottom, so I have x squared, x plus 1 to the positive 3/4, which, as I recall, is what we got over here. So we can do this problem two ways. So look for this problem coming to a quiz near you. Hey, and that's the end of our lesson. I hope you are comfortable enough with this material so that you can do the complex rational expression simplifying. That is the homework assignment with this. Take care, everyone.